let's wrap up section 9.2, and I promise this video is not as long as the one for yesterday was. Now, we're going to look at two-sided tests. All the examples we did yesterday were just one-sided. It was either greater than the null hypothesis or less than the null hypothesis. So two-sided tests are when we say it's not equal. So we think it's just not equal to it, in which case being bigger than or smaller than it matters. So according to the Centers for Disease Control and Prevention website, 50% of high school students have never smoked a cigarette. Tyon wonders whether this national result holds true in his large urban high school. For his AP Statistics class project, Tyon surveys an SRS of 150 students from his school. He gets responses from all 150 students, and 90 say that they have never smoked a cigarette. So what should Tyon conclude? Give appropriate evidence to support your answer. So please pause this as we go along, because I'd actually like you to be able to do this on your own as much as possible. So right now, if you pause and just try to do the state and the plan, then you can hit play and hear what I have to say about it. All right, here we go. In fact, let me get I should have the present mode on. Let's fix that. Okay, much better. So state, we want to perform a test at the alpha equals 0.05 significance level with a null hypothesis of 0.5 and an alternative hypothesis that p does not equal 0.5, where p is the actual proportion of students in Tyon school who would say they have never smoked cigarettes. So we show our significance level, our null hypothesis, our alternative hypothesis, and we define what p is in this problem. Time to plan. If the conditions are met, we should do a one-sample z-test for the population proportion p. Random. He surveyed an SRS of 150 students. Good there. Normal. We can check, based on the null hypothesis is p, that the number of expected successes and failures is 10 or more. We're safe with that. Finally, independent. We are sampling without replacement. He's not picking the same person twice or even letting that be possible. So we do need to check the 10% condition. It is reasonable to assume at a large high school there are at least 10 times 150 or 1,500 students. So that seems reasonable at a large high school. Okay, now it's time for our do and conclude. So I want you to pause here again. You try to finish the rest of this on your own, and then once you're ready, hit play and we'll walk through it. We find our sample proportion. That's 90 over 150. That's about 0.6. Then find our test statistic. We get 2.45. So this is 2.45 standard deviations above the expected mean. So our p-value, we have to double it. Remember, this is symmetric, so if we find the area of one tail and double it, that will tell us the area of the two tails combined. But we're doing this because our alternative hypothesis was that it does not equal. So we care about it being this far or farther in either direction. That's why we have to consider both sides. So using table A or normal CDF, you get a p-value of 0.0071 for just one of the tails. So we do have to double that to 0.0142. So the probability of getting a sample proportion this far away from the mean that it's claimed, either direction, this far or farther away, is only 0.0142, so a 1.42% chance. That is pretty small, and that is certainly less than, our p-value is less than the chosen significance level of 0.05. So we have sufficient evidence to reject the null hypothesis and conclude that the proportion of students at Tyon School who say they have never smoked differs from the national result of 0.5. So this is convincing enough evidence that it's different at his school. So really the only differences with a two-sided test are that in the null hypothesis, the alternative hypothesis, you have does not equal And when the p-value comes, you have to double it to account for both sides and both tails. Here's another example with two-sided. According to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. In a national survey of restaurant employees, 75% said that the work stress had a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this national result holds for their employees. So a random sample of 100 employees finds that 68 answer yes when asked, does work stress have a negative impact on your personal life? Is this good reason to think that the proportion of all employees in this chain who would say yes differs from the national proportion of 0.75? And we'll support our answer with the significance test. Alright, please pause here. I want you guys to try, do your own state, plan. We'll start just with state and plan. We want to perform a test at the alpha equals 0.05 significance level of the null hypothesis p equals 0.75 versus the alternative hypothesis p does not equal 0.75, because we are doing a two-sided test. Now we define p, where p is the actual proportion of restaurant employees who say that work stress has a negative impact on their personal lives. Time to plan. If the conditions are met, we should do a one sample z-test for the population proportion p. And for our tests, the sample is randomly selected. Check. The number of successes and failures are both at least 10. Check. Independent. If there were 100 in the sample, since this is a fairly large restaurant chain, what I should have written here is very likely that there are more than 1,000 workers, but I need to show 10 times 100 equals 1,000. So the sample is less than 10% of the population. All the conditions have been met, so let's run our test. Again, please pause here. I want you guys to try the do and conclude part on your own. Are you done yet? Are you done yet? Good. All right, here we go. Do and conclude. Do. The sample proportion is, did not show up. Sorry, I don't know why the equation is not there, but the sample proportion, it was back here, wasn't it? Where is it? Oh yeah, 0.68. 0.68, because you do 68 over 100. I'm sorry that's not shown up for some reason, but the sample proportion is 0.68. And the corresponding test statistic, which you should show your formula, how you got this, is negative 1.62. So 1.62 standard deviations below the claimed mean. Since this is a two-sided test, we find the p-value for negative 1.62 as our z-score, and then double it, and that gives us 0.1052. Since our p-value is greater than 0.05, we fail to reject the null hypothesis. We don't have enough evidence to conclude that the proportion of restaurant employees at this large restaurant chain who say that work stress has a negative impact on their personal lives is different from the national proportion of 0.75. All right, we're going to talk a little bit about the relationship between confidence intervals and significance tests, especially two-sided significance tests. So this says why confidence intervals actually give more information. Well, the result of significance test is basically just one decision to reject the null or fail to reject the null. And when we reject the null, we're left wondering what the actual proportion might be, because we have no idea if it's just a little bit off or if it's way off or just something in between. So a confidence interval can shed some more light on the issue. So thinking back to the example, I don't remember if it was yesterday or today. Anyway, Tyon found that 90 of an SRS of 150 students said that they had never smoked a cigarette. But before we can start a confidence interval for the population proportion P, we should check that both the number of successes and failures are at least 10. So remember, I talked about the fact that the one difference between the conditions is that the significance test used P naught. We've already done that, so we don't need to do that again, but since we're doing a confidence interval, we need to use P hat. So we proceed with those calculations looking for the number of successes and failures with P hat. And it's 90 and 60. We know that just from the information. He had 90 yes or 90 no's and 60 yeses, however you want to look at it. So we're good. So here's our 95% confidence interval. We've got our P hat, our z-score for 95%. We use our P hat to get our standard deviation, and we get 0.522 to 0.678. So we can then say we're 95% confident that the interval from 0.522 to 6.678 captures the true proportion of students at Tyon's High School who would say that they have never smoked a cigarette. So I just want to try to make it clear what they're communicating here. A significance test is valuable, but it basically just gives us a yes or a no on one single value. That's helpful, but a confidence interval can really offer more than that. It gives us a range of values with a pretty strong indicator that it is in that range of values. Confidence intervals are related to two-sided tests. The 95% confidence interval gives an approximate range of P naughts that would not be rejected by a two-sided test at the alpha equals 0.05 significance level. The link isn't perfect because the standard error used for the confidence interval is based on the sample proportion, while the denominator of the test statistic is based on the value of P naught from the null hypothesis. So again, it's back to that difference between P hat and P naught in the standard deviation. Now it's still very close. It's not telling you this is no good. It's just telling you it's not exact on covering the exact same values. But if you look back at the one we just did, you can think about it as since 0.5, which was the null hypothesis, did not fall in the confidence interval 0.522 to 0.678, we would reject that as it being likely that it's the true one. Even with this, we can't guarantee it because we only have a 95% confidence that the true proportion is in this range. But you note that we rejected the null with the hypothesis test, and we would do the same idea here. We would reject the claim based on the confidence interval because it does not fall in that range. Okay, so 3 points here. First, a two-sided test at a significance level of alpha and a 100 times 1 minus alpha confidence interval gives similar information about the population parameter. In other words, a significance test of 0.05 significance level and a confidence interval, a 95% confidence interval, give very similar information about the population parameter. So similarly, a alpha equals 0.10 significance test or significance level would give us very similar information to a 90% confidence interval. So just one, you kind of go that distance from 0, the other you go that distance from 100. Next up, if the sample proportion falls in the fail to reject null hypothesis region, like the green value that it's pointing to, the resulting 95% confidence interval would include P naught. In that case, both the significance test and the confidence interval would be unable to rule out P naught as a plausible parameter value. So they fail to reject the null. It's going to be the same time that it falls in the confidence interval. But the flip side of that is that if the sample proportion falls in the reject the null hypothesis region, the resulting 95% confidence interval would not include P naught. So in that case, both the significance test and the confidence interval would provide evidence that P naught is not the true parameter value. So just to make sure you understand the picture, It's pointing right now at the P naught that's in the reject the null hypothesis area, and the line segment extending from it represents the confidence interval. So what we're seeing is right here we have the confidence interval, and this green line is the parameter that is claimed by the null hypothesis. So you can see in the one I circled, it is not overlapping with it. So it does not contain the parameter claimed by the null hypothesis. So we would think, doesn't seem likely that that's true. Whereas this one over here, its line segment is the 95% confidence interval. It does intersect with this line. Sorry, I'm not drawing straight lines for some reason. But that would tell us that we don't have enough evidence to go against the null hypothesis. Sorry, I'm having trouble coming off the marker. Let's see. Here we go. Okay. So challenge question. I think it's already answered previously, but let's see if you remember. As we read, something like a 95% confidence interval and a two-sided test, alpha equals a 0.05 significance level, would be very similar in the values that they include in their interval and that the test would not reject. But it actually is just approximately the same, not exactly. Why do you think that is? Well, if you were reading and listening earlier, you know. It's because the confidence interval uses p hat to find its standard deviation, but the significance test uses p naught. So that does make a slight difference between the two. There will be some points where one would reject and one would fail to reject. Or one would contain it, one would reject, one would not contain it, one would fail to reject. Okay, using the information from the previous questions about job stress, create a 95% confidence interval for the proportion of restaurant workers who said that work stress had a negative impact on their lives. So please pause here and give that a try. You don't have to do 4 steps right now, just make the confidence interval. Alright, here it is. We plug in our p hat, our z, and our p hats and our n, and we get an interval of 0.637 to 0.723. So explain what the interval you find tells you about whether the national value holds at the large restaurant chain where the sample was taken. So we would say by this, it is likely, or there is reasonable guess, that the proportion who have job stress affecting their personal life at this restaurant is between 0.637 and 0.723. Anything outside that, we would say, no, not a lot of evidence that that would be true. So if I'm remembering right, and I'm sorry if I'm not, 0.75 was what the national value claimed to be. So that would make us think, no, doesn't seem to hold to the national value. There does not seem to be a match between the national value and the value at this restaurant. And that's all. Good luck with section 9.2. Study hard, look at these homeworks, and you'll do awesome on the quiz. Good luck. I miss you guys.